So when you first looked at the market 2 years ago, you were first referred to it as same plot, shorter film.
Yeah.
So now that we're looking at it 2 years later, do you feel that that still applies?
Yeah, what I meant by same plot, shorter film is I was looking at how HPC was adopted 40 years ago. And my quick, as I was trying to get into this 2 years ago, was go, okay, wherever Cray boxes were being sold 40 years ago, they are going to want to consume the technology, but it'll happen much faster because of cloud. So what we've seen is all the different vendors that you know better than I do that are starting to offer it via the cloud and cloud subscriptions, be it Microsoft, IBM, who else? IonQ's doing it, or they're starting to do it with Microsoft.
Yep,
right?
yep, and
Right?
Honeywell as well.
Honeywell as well. QCware's set up a cloud offering too, right?
They're investing in that space as well.
Right. So the cloud consumption, that is a lot faster to get access to it than when you had to buy the system, wait 6 months to get it shipped, wire it up, and program it. They're able to just get going. So that's what I meant by same plot. It'll go to those same markets, but it'll be a shorter film because cloud compresses the adoption cycle. And we're seeing it more and more. With that, we're also seeing I don't want to call it the collapse of the competing structures, but the people who are investing heavily in superconducting, for example, are partnering so they can get onto ion trap and all those other things. That's happening way faster than it did in I'll call it the traditional mainframe to mini to Intel chips sort of ruling the day. That happened over 30 years, and we're starting to see those alliances happen before they even have a commercial product out there. So it is happening faster. It is the same plot, but it is a shorter film. That's the speed of innovation that's just continuing to accelerate faster than humans can keep up with it.
Okay, so as you've been researching the space, we've heard a lot about this market hype and how it compares to the actual progress happening in the quantum space. So I'm wondering if you can share with us some of the disadvantages and advantages that this hype might apply to the quantum space.
Well, the biggest thing is as classical, the time frame expectations for classical have compressed more and more and more. Product life cycles used to be 18 months, now they're about 6. When you do your M&A used to be once there was kind of a product ready for scale, and then you would acquire it so you could run it through your sales and distribution arms if you were the larger firm. And now it's the time frame is compressing in classical, where you're sort of buying these things when it's just IP before they have product in a lot of cases. So the M&A for traditional investments has been pulling the trigger on the acquisition sooner in the company maturation cycle than it used to. And here what we have with quantum is a mindset of the 90-day shot clock because of activist investors, the expectations for VC to return the money. And there's still pieces of this industry that are in scientific discovery. In other words, we don't have a solution yet to the problem, but we have about 200 to 300 of the brilliant minds working on it. So while there's the promise of an incredible change in performance and speed and precision, right? The time frame is unknown in some ways because the people haven't figured it out yet. Bright people haven't figured it out yet. We know it's going to happen, but we don't know exactly when. So the expectations, the hype sets it up with the business side for an expectation of a shorter amount of time to get there. And the scientists are like, whoa, give us time. We don't know yet. We haven't figured it out. So it's this push-pull on the promise versus the business expectations of how rapidly these things come out based on the way it's accelerated on the classical side. So it's a challenge. VC has to have a longer expectation for the return on investment. And the business leaders who are buying into this hype need to have it dampened, which is why you and I always test like economic advantage with the experts to make sure we're not contributing to the hype, but being as realistic as we can be in something where there's still unknowns. That's why it's so fascinating.
Right, yeah, and I think to add to that, when we were talking to customers at Quantum Tech, and they were being rushed by their superiors to implement quantum computing.
Oh, the barista guy?
Yeah, do you want to mention that one?
Yeah, that was a great one. It was, where was he from?
He was from a healthcare.
Oldham, a
Yeah,
healthcare.
healthcare.
It was a healthcare CIO, and he's there, and his comment was rather sardonically, what he said was, these $15 an hour baristas get a raise to become a $25 an hour blogger, and they're writing about quantum, and then my CEO's coming down to go, why don't we have this? And so he was frustrated with the hype of, we have supremacy, and all of a sudden that should in theory mean we're going to have this massive quantum leap in analytics or some algorithm output. And then when you study what the application was, not to take away from the Google example, it was the best analogy I've seen, and I use it in a write-up that is out or is coming out. It's like a kitty hawk flight. We're looking for the promise of commercial air flight, and where we are with these advancements is sort of the kitty hawk flight. It's been done, but there's a lot more that needs to be added to this for it to be a live business application, or a piece of a live business application.
Okay, so piggybacking off of that question, what can business leaders do to adequately prepare for when quantum computing does become mainstream commercially available?
That's an easy, well, to me, in my head, it's an easy one. You've got to have at least a minimum amount of staff taking advantage of those cloud subscriptions that we talked about. One of them or several of them, I don't know, right? But you have to have a couple people doing what I believe it's QCware talks about, is application discovery. We have the scientists doing the engineering discovery. Science has to discover it. Engineering has to harden it into the componentry. Then there's the need to try to translate what the physicists and the engineers are saying into business. And so the business people need to start, in my opinion, need to start using those developer toolkits to do application discovery, to determine where they can take this powerful new computing architecture and apply it to some of their more persistent, obstinate, challenging components to come up with a breakthrough with either in the precision or the speed of what they're doing.
And so how can a business leader evaluate if they can deliver economic advantage within their organization now, maybe in the next 5 years, the next 10 years?
That's the precision, speed, or cost. Precision is the piece where scientific discovery is still going on. The fidelity of the system, how accurate, if we push the button to say quantum compute this for us, right? We send it over there to get it done. How accurate will the response be that's coming back? How precise will that be? How much faster can it do it relative to classical? I spent 18 months on an effort that I've given up on, as you know, talking to great minds, trying to create a single mathematical proof point from Moore's law to quantum, whatever you want to call it. I'll call it quantum's law. I've been trying that. I'm failing miserably, so I've kind of put it aside for now. And precision, speed, and cost is a way to evaluate it. How accurate is it? How much faster is it? Right now, the glib marketing phrase I use is a square root of now, which is even in itself inaccurate. But whatever, ceteris paribus, you're doing it in classical, you can put it over in quantum. Whatever the time is now, it'll be the square root of that coming out of quantum. What advantage do you get from that? And it's not just in the computing cycles. It's also, if you have that greater precision, what can that do for the other elements of the business you're supporting? If you can be more precise in your modeling for material science, that's more dry lab work, so then you have less wet lab work. So it's not just to compare the compute cost, it's a compare of the optimization of your normal flows if you can get the insight, and then how precise is that insight, right? So it's precision, speed, and cost. That's how you evaluate it.
Yeah, so if you're curious and learning more about what Geoff and I are researching in the quantum computing space, feel free to reach out, ask us about our quantum computing market landscape, which is semi-annual, just came out a few weeks ago.
Furthermore, if there's anything that we have said here that you disagree with, we want to hear about it, because we're learning as we go, and we're trying to serve as a business translator as liberal arts majors after engaging with people with PhDs in physics. So we're way outside of our comfort zone trying to gain the understanding of the science and the engineering so we can translate it into what the business or academic research benefits are going to be, and what are the starting points and the proof points for that as this thing gets closer and closer to having an economic advantage. It's a lot of fun, but it's very uncertain right now.